Welcome to the course on blockchain. So, till now we have looked into the basic blockchain architecture, its use cases like Bitcoin and smart contracts, and then we have looked into the basic cryptographic primitives in blockchain, like we have looked into the hash and cryptographic hash functions and digital signatures, and we have also looked into that how digital signatures and cryptographic hash functions are used in the context of blockchain to make it secure and tamper proof. So, now we will look into the interesting topic of Bitcoin, which is emerged as a digital cryptocurrency, but the fundamentals or the base of Bitcoin is depending on the blockchain architecture. So, this entire Bitcoin network it supports blockchain, and blockchain works as a fundamental building block behind the development of Bitcoin. So, we look into the different aspects of Bitcoin, how this digital currency is designed, how you take the technical aspects as well as the economical aspects together, and have a nice currency system which can replace the existing currency system with the properties like permissionless, where anyone can join in that cryptocurrency system, or there will be no control on that particular currency system, no government or bank will have control on that. So, how we can utilize this concept of blockchain to develop into such kind of cryptocurrency, that we will look into the next 3 lectures. So, let us start with the discussion of Bitcoin. So, by the definition, so this definition I have taken from one Bitcoin website. So, it details that Bitcoin is a decentralized digital currency which enable instant payments to anyone anywhere in the world. So, it is a cross country payment system that was one of the primary objective behind the development of Bitcoin, and another objective was that we want to have a cross country transaction support such that no government or organization will have a control over it. And the nice properties of Bitcoin are this decentralized architecture, which actually helps it to get a system where no one has external control over this currency system. It works over a complete peer-to-peer network, and it supports different levels of security, so that the entire system becomes tamper proof, but it works in a nice way. So, we do not have any kind of central authority. So, the entire Bitcoin network works in the peer-to-peer principle, peer-to-peer technology principles. So, in Bitcoin we have two broad operations. One is the transaction management, that means transferring of Bitcoins from one user to another. Like you want to purchase something, you can purchase it by utilizing the Bitcoin, or you want to make some transfer of money from someone in India to someone say in USA. So, you can do it using Bitcoins. And the second interesting aspect or the important aspect of Bitcoin is the money issuance, where you need to regulate the monetary base of Bitcoin, like the economical aspects of a coin base of a digital currency, that need to be ensured, where in our normal banking system we have the banking authority, the central bank, which will regulate the money inside the country. They will create the new money, or with time they can demolish or they can drop the old money, and that control, that in what rate the monies will be generated, that is in general controlled by the central banking system. But in case of a digital currency system which works over a peer-to-peer network, ensuring that is a kind of interesting but difficult thing, and Bitcoin actually solves that problem by utilizing a set of technical concepts that we will look into little details. So, the basics of the Bitcoin is this creation of coins, the economic aspects that I have mentioned earlier, like you require a kind of controlled supply of money. So, you must limit the currency to have their value. If you put up a lot of currency in the system, it will gradually reduce the value of that particular currency. So, that comes from the economic concept. So, any such maliciously generated currency, you need to reject those and you need to accept the actual currency which are flowing in your system. Now, these bitcoins, the new bitcoins that need to be generated like a normal currency. So, these new bitcoins, they are generated during the bitcoin mining timing. So, each time a user discovers a new block, that particular procedure we call mining. So, the methodology for bitcoin mining we will look into more details, but whenever a particular person generates a new block, during that time the system generates some new bitcoin, and that person who is investing his or her power and system power and time to generate the new blocks by participating in the mining procedure, for those person they are awarded with that newly generated bitcoin. But as I have mentioned that this flow of money or the generation of new bitcoins, that need to be regulated. So, you should have some rate at which you need to adjust the block creation. So, in case of standard bitcoin architecture, the rate of block creation, it is adjusted over every 2016 blocks, and the aim is to have a constant of 2-week adjustment period, like at every 2 week you will readjust the amount of money that has been generated by mining the blocks. So, to regulate the money, the number of bitcoins which are generated per block, it is set to decrease geometrically, like with time the amount of money that is awarded by for mining a new block that got dropped, that get decreased with a rate of 50% reduction for every 2,10,000 blocks, which takes approximately 4 years. That means that approximately 4 years the price of mining, like if you participate in the mining procedure and if you can successfully mine a new block, the amount of award that you will get from the Bitcoin network, that will gradually drop at that gradually drop at every 4 years. So, this reduction with time, this reduces the amount of bitcoins which is generated per block. So, theoretical limit for the total bitcoins which you can generate with this particular limit, which it is slightly less than 21 million. So, once you have generated some 21 millions of bitcoin, after that you will find that by participating in the mining procedure you will not get any reward. So, that way as the time progresses the miner will get less reward, but the question comes that how can you pay them or what should be the incentive for them for participating in the mining procedure, because currently the miners participate in the mining procedure because they can get some bitcoin by participating in the mining. In the mining procedure they have to solve some mathematical puzzle for which they have to invest the system powers and the time. By investing that system powers and time in the mining procedure, if the mining is successful they are rewarded with some bitcoin. But as that will get decreased with time, and once this approximately 21 millions bitcoins are generated, the system will not generate any new bitcoin. So, the miners will not get paid from the network for participating in the mining procedure. So, in that case what can be their incentive, like you can use the transaction fee, you can increase the transaction fee or get more transaction fee from the participating user to pay them, to pay the miners for participating in the mining procedure. So, that way that is the normal rule of economy, where you establish a system, and once the system is well established then you imply some charges on the users who will make a transaction, and once the user will make a transaction, with the transaction they have to provide certain transaction fee, and that transaction fee will be utilized to make a payment to the miners who will participate in the new block mining procedure. So, that is a kind of broad objective. Now, this is a kind of projected bitcoins with respect to time. So, around this 3rd January 2009, during that time when the initial time the block was generated, during that time you can get around 50 Bitcoin per block. So, if you generate a new block, for every block you can get 50 Bitcoin. So, as the time progressed, for the first 4 years it was 50 Bitcoin, then from 28/11/2012 it reduces to 25 Bitcoin per block, then from 9/7/2016 it will get 12.50 Bitcoin per block, then it is again gradually reduced to 6.25 Bitcoin per block. That way gradually the price of Bitcoin or the reward amount that you can get by participating in the mining procedure or generating a new block, that will get reduced over time. So, this chart it gives a nice indication about how much time it will take to completely generated the targeted Bitcoin. Means by the time this Bitcoin reward per block, that will get nearly 0 or close to 0, and by doing this mathematical calculation you can find out that once it reaches to 21 million Bitcoins in the network, then you will not get any further reward from the system. Okay. Now, whenever you are sending the payments in the Bitcoin network, you need to ensure that any other person cannot spend the Bitcoin owned by one person. So, if cannot spend the Bitcoin which is owned by Alice by creating the transaction in her name. So, the intruders in the network, they will not be able to create some kind of false transaction. To ensure that Bitcoin uses the public key cryptography, as I have mentioned earlier, that it uses this digital signature concept along with ECDSA digital signature algorithm to make and verify the transactions using digital signatures. So, each person who are participating in the Bitcoin network, they has one or more such addresses with an associated pair of public and private key. So, every user can have one or more address based on your wallet or how many addresses you can create, but every Bitcoin address they will get associated with a pair of public and a private key. Now, say Alice wants to transfer some Bitcoin to Bob. So, what Alice can do? Alice can sign the transaction. So, Alice can create a transaction, and along with that transaction Alice can put her signature and send that to Bob. And during putting the signature, as we have discussed earlier during the crypto primitives, that Alice can use her private key to sign that particular transaction and send the signature along with the transaction. Now, anyone in the network, they can validate this transaction with Alice's public key. So, they can decrypt the transaction with the public key and validate that whether the transaction is originated from Alice or not. So, these are the set of steps that Alice has to follow if she wants to make some transfer of certain Bitcoins to Bob. So, first Bob sent his address to Alice. So, this is a cryptographically generated address which is transferred to Alice. Now, Alice adds Bob address and the amount of Bitcoin that need to be transferred in a transaction message. So, she construct a transaction message with that particular transaction information, that the transaction is from Alice's address to Bob address, and along with that you put the amount of Bitcoin that need to be transferred. Now, Alice signed that transaction with her private key and announces the public key with which anyone can validate that transaction. Then Alice broadcasts this transaction in the Bitcoin network for all to see that transaction. So, the broad idea is that Alice construct the transaction, put her signature along with the transaction and also put the public key to validate the transaction, then broadcast the transaction in the Bitcoin network. Now, whenever you are creating the transaction or the Alice is creating the transaction in a digital currency, you may have the problem of double spending. So, what is double spending? It is like that the same Bitcoin, it is used for more than one transaction. So, for example, Alice has total 50 Bitcoin, and the same amount of Bitcoin she has transferred to Bob, and says she has transferred it to Charlie. Now, these transactions are kind of double spending, that both the transactions cannot be valid simultaneously. Now, in a centralized system like a banking agency, this is very easy to validate such kind of double spending. So, whenever you are submitting the transaction to the bank can validate that whether you are doing a double spending, like you have say 1000 rupees in your hand, but you are making 2 transactions with 1000 rupees. So, bank can validate that and accordingly can take the necessary actions, but the question comes that in a decentralized network, how can you prevent double spending so that someone will not be able to make 2 transactions with the same Bitcoins. So, to prevent double spending, we use this blockchain in Bitcoin. So, the details about the transactions which are sent, these transactions are forwarded to all the users in the Bitcoin network or as many as other computers as possible, and we use this blockchain, which is a constantly growing chain of blocks to contain a record of all such transactions, and this blockchain is maintained by all the peers in the Bitcoin network. So, everyone has a copy of the blockchain. So, in case of a Bitcoin network, so all the nodes who are there in the network, they maintain a copy of blockchain with them. So, everyone has the same copy of blockchain which contains all the transactions. So, the transactions they are put inside these blockchains and everyone can validate those transactions as well. Now, to get a transaction accepted for a chain, the transaction blocks they need to be validated and they also should include something called the proof of work. So, this proof of work is the Bitcoin consensus algorithm that we will discuss later on, where the miners need to solve a computationally difficult hash problem based on a challenge and they need to solve a hash puzzle that we had discussed earlier. That means, they need to find out something like this, like they need to find out y with a hash value of x and some nonce. So, the miners need to find out these nonce where x and y are known. So, ideally in case of Bitcoin, x is known, x is a record of the previous hash and the set of transactions organized in a Merkle tree and a Merkle root, and y has certain constraints like y should have certain number of zeros at the beginning. So, that was the constraint which is imposed on y. Now, the target of the miner is to find out these nonce so that they can find out a hash value y with this constraint, like there would be certain number of zeros at the prefix of y. So, y will look like something like there is a set of zeros and followed by say some numbers. So, y will look something like this. So, there would be certain number of zeros at the beginning which is put as the puzzle for this particular mining problem in Bitcoin. So, the attacker not the attacker sorry, the miners need to find out the nonce so that y looks like this. So, finding out this kind of a solution for this kind of puzzle, as we have discussed earlier, it is very difficult. You do not have any kind of computationally efficient algorithm to solve this kind of puzzle, and the best way of doing it is to try with different random nonce or different values of nonce. So, the miners actually find out these nonce values which work like a proof of work. So, the response to this particular challenge or the solution of this particular puzzle is this nonce value which work as the proof of work. So, this particular algorithm is known as the proof of work, which is used to validate a particular block in the blockchain. Now, blockchain it ensures that, as we have discussed earlier, like blockchain ensures because of this hash pointer property and every block also contain the hash of the previous block. So, the entire thing is tamper proof. So, if any block is modified, you need to modify all the subsequent blocks, and the hash for all the blocks need to be recomputed. Now, these things we have mentioned earlier briefly, that when multiple valid continuation to this chain appear, only the longest such branch is accepted and it is then extended further. So, we always consider the longest chain in the Bitcoin network. We will go to that little details in the next lecture, that how we actually achieve this. And once a transaction is committed in the blockchain, then everyone in the network can validate the transaction by using Alice's public address. So, this somehow or prevents the double spending in Bitcoin. Like if there are two transactions with the same Bitcoin, everyone will be able to see that, and the miners will not be include both the transactions in the same block. And if a transaction is already included in a block, then the same transaction, same Bitcoin, that will not be used in the next block or in any of the subsequent block. By maintaining this kind of blockchain architecture, which are already got validated, you can this way prevent the double spending in the network. Now, another concept in the context of Bitcoin is anonymity. Like this Bitcoin is permissionless, that you do not need any setup of any account, or you do not require any email address, username or password to log in to your wallet. Anytime you can join in the network. Now, whenever you are joining in the network, you do not again need to register your public and the private keys. The wallet can generate the public and the private keys for you. Now, the interesting part is this Bitcoin address, which is used for transaction. So, this Bitcoin address are not the username or the identity. So, they do not carry the identity of a particular user. They are some kind of anonymous address through which you will not be able to guess who is the actual user. And a single user can have more than one addresses as well. So, let us look into a brief that how these addresses are generated. So, these Bitcoin addresses are basically corresponds to, it is a mathematical correspondence of the public key which is used by the user. So, the broad algorithm is something like this. So, you have generated your public key. So, once you have generated your public key, say Alice has generated her public key. Say this is the public key for Alice. So, what you do that once you have this public key for Alice, which is generated by this ECDSA algorithm, you apply a hash over that. Normally, we apply a 160-bit hash function on top of that. So, after applying the hash function on top of that, you extract the first few bits out of that hash and use that as your address. So, a sample Bitcoin address looks something like this. So, this is a sample Bitcoin address which is generated by applying the hash function over the public key and then performing certain other operations. So, there are multiple versions of Bitcoin addresses, different addresses applies different set of operations, but the broad idea is that you have the public key, on the public key you apply a hash algorithm, 160-bit hash algorithm, and then by taking the hash value and processing over the, doing some further processing over the hash value, finally you generate an address like this. So, by looking into this address, it is difficult to guess who is the actual user. Now, as I have mentioned that each person can have more than one such addresses, even some Bitcoin users they have many of such addresses, and each of the address will have their own value. So, that way it is difficult to know that which person owns the account. So, this particularly prevents the anonymity of Bitcoin transactions. By you can always see the transactions inside the blockchain, but you have no way to identify who the corresponding user is. Now, Bitcoin has a nice concept called Bitcoin script. So, what is Bitcoin script? Say Alice makes a transaction of some 20 Bitcoin to Bob. Now, how Bob will claim that transactions, how Bob will know that those transactions are intended for him and no one else other than Alice is actually initiated that transaction. Now, the broad concept we have discussed earlier, the broad concept says that you include the signature of Alice along with the transaction. So, along with the transactions you include two other things. So, whenever you are sending some transactions, so along with the transactions you send a signature and you send a public key, say you send a public key of Alice. So, these three informations are transferred, and if these three information are transferred, then Bob can look into this information and Bob can find out that, well, in this transaction is from say A to B, where A is the address of Alice and B is the address of Bob, and by verifying this signature with this public key, Alice can find out Bob can find out that this transaction is a valid transaction, which is actually came from Alice and no one else in the network, and this is not a kind of forced transaction in the network. So, after doing this validity check on this top of this transaction, then Bob can accept the transaction. Now, every transaction, it is characterized by two parameters. One is called like the input parameter. The input parameter is something like that the input of a transaction is Bob is receiving some bitcoins, and the output of a transaction is Alice is sending some bitcoin to Bob. So, it is something like this, that Alice is making a transaction of say bitcoin 20 to Bob. So, Bob is receiving this bitcoin 20 from Alice. So, this is the input of the transaction, that Bob is receiving bitcoin 20, and this is the output of the transaction or out of the transaction, which says that Alice is transferring some bitcoin 20. Now, what we need to determine here, that the input of a transaction correctly claims a transaction output. So, the transaction which has been made from Alice, it is a correct transaction and it is intended for Bob only. So, for that what we do, rather than transferring the public key or transferring the signature, what Bitcoin does, Bitcoin transfers some code, which is some script. So, Bitcoin script is a programming language to validate Bitcoin transactions. So, it is a list of transactions or list of instruction records with each transaction, and it describes that how the next person who can gain access to the Bitcoin if that person wants to spend them. Now, Bitcoin script is a fork like language, it is a stack based and process left to right. We will see an example of this fork language. So, this is an example of a Bitcoin script. We will go to the details of this particular script, that what does it mean and what are the individual operators of this script looks like. So, before going to that, as this Bitcoin script is inspired from this fork language, let us look briefly about how fork works. So, this fork is a stack based computer programming language, which was originally designed by Charles Moore. It is a procedural programming language without any type checking. It uses a stack for recursive subroutine computation, and it uses this reverse polish notation or the postfix notation to make a computation. So, what is a postfix notation? Say in postfix notation, say you want to make a addition of 2 plus 3, in a postfix notation this operator is written after the operand. So, in the postfix notation it is written as 2 3 plus. So, if you convert infix operation, so this operation we called as a infix operation. So, if you convert a infix operation to a postfix operation, the advantage is that you can use a stack to correctly do the computation of that particular postfix operation. So, here is a sample execution of fork using this reverse polish notation. Say you want to make this computation, if you want to make this computation, you first put 30 to the stack, then once you have put the 30 to the stack, then you encounter 10, 10 is also pushed in the stack, then you come to the next thing is a multiplication operator. Whenever you are getting a multiplication operator, you pop out the top 2 element from the stack and do the multiplication. So, the multiplication result is 300, it is again pushed to the stack. then the next operand is 15, you, if there is an operand, you push it in the stack, and after that you are getting a plus. Whenever you are getting a plus, you pop out the top 2 operand from the stack and perform the operation, push it again in the stack, and you got 315, and finally you get this CR instruction. Whenever you are getting the CR instruction, you finally get the output which is there at the top of the stack as result. So, the idea in this execution of RPN representation using a stack is that whenever you are having some kind of operand like 30 or 10, and whenever you have the operand, then you push them in the stack, and whenever you are getting some operator like this start. So, whenever you have some operator, then you, if this is a binary operator, so you pop out top 2 element from the stack, then you perform the operation, and then push the result in the stack. Okay. So, that way you can perform the execution using this reverse polish notation. So, this is again a fourth sample code and the corresponding C code representation. This is a fourth subroutine. A fourth subroutine is named as an word. So, in this subroutine, so this particular instruction in the brackets, it means that we are taking one input and we are possibly producing some other output. So, this is in the fourth representation. Then this particular instruction is equivalent to C instruction that v less than 6. If v less than 6 is true, then you return 5, otherwise you return v minus 1. Now, whenever you are representing in fourth, so this dupe operation basically make a duplicate of whatever is there in the stack top. So, it is like that whatever input you are getting here, so that input will be inserted in the stack. So, you are, if you are getting a value say 7, 7 will be inserted in the stack, then you will get a 6, 6 will be inserted in the stack, then you will get a operand. Whenever you are getting the operand, you compare this top 2 element in the stack. By comparing that you find out whether that is true or false. So, here 6 is less than you making this operand. So, 7 is less than 6, it is false. So, the output of this operation is false. So, you take a false and push it inside the stack. So, in the stack now you will have false, then you execute this if statement. So, if it is false, so that means you will directly jump to the else statement, and in else statement it is saying that whatever you make a minus. So, this duplicate element has duplicated the entry in the stack stop. So, you make a minus from there, and after doing the minus, whatever be the result, you pop it out. So, the entire thing you can execute in the stack in this way. So, you have the stack there, whatever be the input, say the 7 was the input, you have put that input in the stack, then there is a dupe. So, this dupe duplicate whatever there is in the stack. So, this duplicate will duplicate the 7 in the stack, then there is operand, you push it in the stack, make this comparison. Whenever the comparison is there, by doing the comparison the result is false. So, you pop this out and put false there, then based on the if statement it comes to this else part because it is false. So, once it comes to false, then whatever be there in the stack top, you have a 1. So, you push 1 there, and then you have a operand minus, then this minus you make a 7 minus 1, it comes to be 6, and then 6 is returned from this execution. So, it becomes equivalent to the corresponding C code. So, this is all about the Forth programming language. In the next class, we will see that how Bitcoin script is actually extended on top of this Forth programming language, and it performs the input and the output operation for the Bitcoin transactions. So, we will see those details in the next class. So, that is all about today's class. Thank you.